In this lesson, we're going to look at a second JavaScript client against a REST-style service. In this case, the REST-style service is the Predictions3 service, which we studied earlier, and that service is implemented in JAX-RS. You can see that I've got a browser open, and what you see displayed as items in an unordered list are the 32 predictions. The HTML source is mostly JavaScript. So all of this is the JavaScript. The body of the HTML document that's downloaded to the browser is empty except for the placeholder for the unordered list. The JavaScript makes a call against the Predictions3 service, gets the data in JSON form, and then generates what we see here. Now, there's a challenge here. The Predictions3 service supports all of the CRUD operations. In particular, it supports post, the creation of new predictions, put, the editing of existing predictions, and delete, of course, the removal of existing predictions. So what we're seeing here in the browser might already be out of date. In other words, some other client may have issued a post request, a put request, a delete request that changes the predictions so that we're not seeing the current version. The challenge is to use JavaScript to ensure that what we see displayed here in the browser reflects the actual data. You can imagine the same scenario in a real-world application. For example, we might be looking at a product list, and the product list might be subject to change continually over the course of a day, and so we want to make sure that the client who is looking at the product list is looking at the most current version. So let me now do an overview of the various approaches to ensuring that the data are up to date. There are two general approaches, and they go by the quaint names push and pull. Let me quickly characterize each. In the push approach, on the service side, there's a list of connected clients, and if there's an important change to the data, the server on the service side might then push those changes down to clients. So for example, this might work well in a multiplayer online game where you have a central server that maintains the state of the game, records new moves, and so forth. A second approach, and it's the one that is used here, is the so-called pull approach. Each client regularly pulls the service to pick up any changes. In this particular case, the JavaScript client, it's written again in jQuery, embedded in the HTML page, does this every 5 seconds or so. Before we look at the JavaScript code, let me do a quick survey of the pieces of this example. First, the Predictions3 WAR file, which is included among the working files, needs to be deployed. Once again, I'm using Tomcat for that. This version of the prediction service supports all of the CRUD operations, so we're going to be able to test whether this polling does in fact work. Poll.html is the displayed page we were just looking at. It resides in a WAR file called ajax.war. I'll get to the name when we look at the actual code, and it uses jQuery to poll the Predictions3 service. In this case, it does so every 5 seconds. We're in a position now to test whether the polling actually works. So what we can do is display the page in the browser, in a separate prompt, issue a curl command. And here's the sample that I'm going to use that will delete one of the predictions. And that change in the predictions should be picked up in about 5 seconds or so. And the new revised list should then be displayed in the browser. We can also do more extensive testing. Earlier on, we looked at the file curlstestrs.pl, which runs a series of tests against the Predictions3 service. But for our purposes, this preliminary test should be good enough.